Who else was in the class? I'm trying to remember. I know them all. Here, hold this.
Yeah. In the previous clip, Maddie seemed to slow down when her arms were open with the weights, rather than when she was closed and she went faster. Why does this happen? Well, rotational inertia. Rotational inertia is a scalar value which tells us how difficult it is to change the rotational velocity of an object around a given rotational axis.
So what does this really mean? Well, inertia is best shown through the equation, where inertia equals the sum of the masses times the radius squared. In this case, radius means the distance of each mass from the circle. Now, inertia changes depending on what object you are putting your masses on. So, for example, if you're calculating the inertia from a sphere, where the center of rotation is at the center of the sphere, your equation would be 2/5 times mass times r squared. For a solid cylinder, it would be 1/2 times mass times r squared.
Because the equation is I equals mr squared, then the units will be kilograms times meters squared.
The difference in rotational inertia is affected by the size of the radius. So here we have these two examples. In this one, you can see that the balls are all really close together, which means the weight is closer to the middle, so the radius is much smaller. This means that this one should go faster. This one here, you can see the balls are a little further spread out, so the radius is bigger, which means it should go slower. So if we look at this example here, you can see that if I were to roll this down at the speed, this means this one should go a bit slower.
This demonstration showed when the masses were farther away, the circle moved slower because your inertia was bigger, and inertia is the resistance to acceleration. So when the masses were much closer to the center, that meant that they would move faster because there was less resistance to acceleration.
So we can do an example problem. Say you throw a frisbee. Let's calculate the rotational inertia of the frisbee if it has a mass of 0.25 kilograms and a radius of 15 centimeters. The equation for rotational inertia is I equals mr squared. So we can set m equal to 0.25 kilograms, and 15 centimeters is the same as 0.15 meters. So we have 0.25 times 0.15 squared, which gives us 0.005625 kilograms times meters squared. But let's say that you have a slightly bigger frisbee and the radius is instead 20 centimeters. Then instead, your rotational inertia will be equal to 0.25 times 0.20 squared, which is 0.01 kilograms meters squared. That is slightly larger, so the larger frisbee will rotate slower.
A real-life example of this is with ice skaters. Have you ever wondered why, when they spin and jump, why they put their arms so close to their body? It's because it helps them rotate faster. If their arms were out, they would not be able to pick up enough speed to finish their turns in the air, and they would just fall when they hit the ground.
Thank you for watching!